Welcome to this explainer. Today, we're unpacking the big picture of global climate systems. We so often hear about climate change in these isolated little fragments, right? A melting iceberg over here, a flooded street over there, maybe some flashy new corporate climate pledge. But today, we're connecting the dots. We are going to trace a direct line from the rapidly melting Arctic ice straight to the sinking of global megacities and right down to the invisible carbon footprint of the shirt on your back or the phone in your pocket. Because honestly, understanding this massive interconnected system is the only way to truly grasp the scale of the disruptions we're facing today. Let's get into it.
Okay, here is our roadmap for today. We'll start with Earth's fragile tipping points, move into sinking cities and divided responses, look at the true cost of everyday products, tackle the corporate greenwashing crisis, and finally, wrap up with some scalable solutions.
Part 1. Earth's fragile tipping points. The domino effect begins.
We really have to start our journey at the poles, because the changes happening in the Arctic, they are the very first domino in a massive chain reaction. Think of our stable climate system as a ball resting comfortably at the bottom of a deep valley. As greenhouse gases warm the planet, the floor of that valley starts to flatten out. We lose that stability. And once the climate ball rolls out of its stable valley and crosses a critical threshold, what we call a tipping point, it locks in large-scale, entirely irreversible changes for centuries, maybe millennia. The ball basically falls into a completely new, altered valley, and there is no way we can easily push it back up, even if we were to magically stop all warming forces tomorrow.
So one of the primary drivers pushing us toward those tipping points is the albedo effect, and it works exactly like wearing dark clothing on a scorching summer day. When you wear a white shirt, it reflects the sun, keeping you cool, right? Well, that is exactly what light-colored Arctic sea ice does. It reflects up to 90% of incoming solar radiation right back into space. It literally acts as the planet's air conditioner. But as that multi-year ice melts away, it exposes the dark ocean water underneath. And that dark water, it absorbs over 90% of the solar energy. This creates a massive positive feedback loop, causing what's known as Arctic amplification. It's why polar latitudes are now warming about 4 times faster than the global average. That is huge.
And this rapid warming isn't just some abstract scientific concept. It has devastating, immediate impacts on real human lives. Take the indigenous Sami people in Northern Europe. Reindeer husbandry is the absolute foundation of their culture. But because the region is warming at such a crazy speed, they're seeing these totally unprecedented winter rain-on-snow events. The rain falls and then quickly freezes, creating this rock-hard layer of ground ice. This traps the reindeer's primary food source, lichen, under an impenetrable barrier. As Sami herder Henrik Blind puts it, their entire culture is written in snow. So the loss of these predictable winter patterns is literally threatening an ancestral way of life that has thrived for generations.
This loss of ice ripples right down through the entire ecosystem. Consider this mind-blowing number: 1 inch. Up in northern Alaska, the hunting season for bearded seals, which the locals call ugruk, is shrinking by 1 day every single year due to thinning ice. Because the stable sea ice keeps retreating, these seals are forced to swim up to 50 kilometers away from their feeding grounds just to find a piece of ice to rest on. It totally exhausts them. In fact, studies led by the native village of Kotzebue found that all this extra swimming burns so much energy, it's drastically reduced the seal's protective blubber from a healthy 3 inches down to just 1 single inch.
Moving on to Part 2, Sinking Cities, Divided Responses, the Frontlines of Rising Seas.
Obviously, when polar ice melts, all that water pushes global sea levels higher, and that directly threatens our coastlines. We're seeing some wild differences in how frontline cities are responding, and the economic stakes are absolutely staggering. Miami, for example, is pouring $40 million into localized adaptation, things like converting vulnerable septic systems to sewers and raising roads. And economic models project that'll avoid about $3.2 billion in structural losses by 2040. Good investment, right? But then you look at Jakarta, Indonesia. They are sinking so rapidly from groundwater extraction combined with those rising seas that they're proposing a massive $60 billion seawall. Meanwhile, Lagos, Nigeria is staring down a $40 billion cost of inaction and is trying to build elite privatized land reclamation projects.
Now, these different adaptation strategies reveal a stark contrast, creating what researchers call climate apartheid. In Lagos, for more resilience projects like the Eco-Atlantic Seawall rely on a highly engineered gray infrastructure to protect wealthy business districts. But here's the catch. These state-led projects have often resulted in the demolition of informal coastal settlements without any compensation. So how did the displaced poor survive? Through absolutely incredible bottom-up resilience.
In the Makoko settlement, residents are adapting on the fly. They're building homes on stilts and literally filling their floors with melted plastic waste just to stay above the rising tides. It's a tale of two entirely different realities.
And the sheer scale of this vulnerability becomes even more profound when you think about this number, 175 million. That is the entire population squeezed into Bangladesh, which is a country roughly the size of Iowa. They are dealing with compounding threats from melting Himalayan glaciers on one side and rising sea levels on the other. The riverbank erosion there is so severe it displaces over 50,000 families every single year. It has completely erased the ancestral lands of communities like the Manta people. Because their physical land has literally washed away, the Manta now live entirely on small boats. This leaves them legally landless and totally cut off from basic state services like healthcare and education.
Back at the policy level, those massive engineering interventions, like Jakarta's proposed $60 billion seawall, create what spatial modelers call a coastal moral hazard. By signaling that the state will just build a giant wall to protect the shoreline, it actually encourages real estate developers to keep sinking capital into these high-risk sinking zones. It incentivizes the exact opposite of what we need, which is a managed retreat. The reality of this hazard is so severe that the Indonesian government is basically throwing in the towel on Jakarta. They're spending $33 billion to relocate their entire capital city 100 miles away to higher ground.
All right, Section 3, the true cost of products, tracing the root causes.
To really understand what's driving all that melting ice in those sinking coastlines, we have to look closely at everyday items, like a standard cotton t-shirt. Based on a massive benchmark of 10,000 life cycle assessment simulations, a single t-shirt emits about 3 kilograms of carbon equivalent. But here's the kicker. Over 60% of those emissions come from the manufacturing phase alone. We're talking about the highly energy-intensive processes of forming the yarn and dyeing the fabric. So the true environmental cost of fast fashion is heavily front-loaded way before you even put the shirt on for the first time.
And when we pivot to global food systems, which, by the way, generate roughly 30% of all human-caused emissions, the data is incredibly stark. A standard quarter-pound beef patty carries a carbon footprint of 4.22 kilograms. This is largely driven by what's called enteric fermentation, which is just a fancy way of saying cow burps that release methane, a gas that's 28 times more potent than CO2. But shifting what we eat makes a monumental difference. The data clearly shows that swapping to a plant-based alternative, like the Beyond Burger 4.0, drops that footprint down to just 0.51 kilograms. That's a staggering 88% reduction in greenhouse gas impacts, plus massive savings in land and water use.
Okay, but what about tech? Yep, even our high-tech devices carry heavy invisible footprints. Take the Apple iPhone 17, for instance. It emits 55 kilograms of carbon over its life cycle. And you'll notice a familiar pattern here. 76% of that entire footprint comes purely from production materials and electricity. It's exactly why decarbonizing the supply chain is absolutely critical. To combat this, circularity is the new name of the game. The iPhone 17 now incorporates 30% total recycled material, including 100% recycled cobalt and gold. And that is a huge, critical step in chopping down that massive manufacturing footprint.
Section 4. The corporate greenwashing crisis. The reality of pledges.
So now we need to look at the accountability of the corporations actually manufacturing all these high-impact products. Companies are constantly blanketing the media with bold net zero and carbon neutral claims, but we have to ask the hard question. Are these corporate climate pledges actually working to reduce global emissions? Do they align with the physical reality of the tipping points we just talked about? Well, according to data from the latest Corporate Climate Responsibility Monitor, there is a massive gap between public PR and actual empirical emission reductions.
The reality of these pledges really boils down to something called Scope 3 emissions. Now, Scope 1 and 2 cover a company's direct operations and the electricity they buy. Pretty straightforward. But Scope 3 covers the entire value chain, the suppliers pulling the materials out of the ground and the consumers actually using the products. For many massive corporations like automotive manufacturers, Scope 3 accounts for up to 99% of their total carbon footprint. Yet there is a massive loophole. Many corporations strategically exclude Scope 3 from their reduction targets. It allows them to paint an incredibly exaggerated picture of their climate leadership while completely ignoring the vast majority of their actual real-world impact.
And it gets wilder. Instead of doing the really hard work to physically decarbonize those supply chains, many companies turn to the voluntary carbon market to just buy offset credits. But astoundingly, a recent analysis of the largest carbon offset projects globally found that 80% of retired credits, representing nearly 48 million offsets, were deemed problematic.
This means they carried extremely high risks of not actually providing any additional emission reductions whatsoever, or they were forestry projects highly vulnerable to just burning down. It exposes a massive systemic integrity failure in how we are supposedly tracking corporate accountability today.
Finally, Section 5, Scalable Solutions and Adaptation, Changing the Trajectory.
Look, despite these immense systemic challenges, we are definitely not without tools. Just look at the scalable innovation happening all over the world right now. Take agrovoltaics. By elevating solar panels over agricultural crops, we protect the plants from extreme weather, we slash water evaporation, and we generate renewable power all at once. We're essentially doubling our land use efficiency. In the tech world, AI-optimized energy grids recently secured $6 billion in funding to use machine learning to perfectly balance power demand. And over in East Africa, we're seeing a massive, incredibly rapid transition of urban fleets over to electric motorcycles, slashing transport emissions and radically improving local air quality.
But tech isn't enough. We also absolutely need policy innovations, especially for those sinking coastal cities we discussed earlier. To protect vulnerable urban populations without causing what's known as climate gentrification, where the rich just buy up the high ground and displace low-income residents, experts recommend a managed retreat. This boils down to 3 proactive steps: completely prohibiting new development in flood zones, massively expanding voluntary property buyouts, and heavily directing public infrastructure funding toward transit corridors on higher ground. This ensures equitable housing, rather than just waiting for disaster and relying on crazy expensive reactive gray infrastructure like giant seawalls.
I'll leave you with this final thought to ponder as we close out this explainer. Today, we've connected the dots from the thinning blubber of Arctic seals right to the 55 kilograms of carbon embedded in your smartphone to the elite seawalls fracturing communities in Lagos. Understanding how all of this is intertwined is an absolutely vital first step. But the ultimate question remains: if our daily consumption drives the melting of the Arctic and the flooding of global cities, how will we use this understanding to demand genuine accountability and implement scalable solutions? How will we secure our collective future before we roll completely past that final point of no return?